Welcome. This is Serverless, not so FaaS. I'm Matt Stine. You can find me on Twitter there at mstine. I mostly use Twitter to amuse myself, so if you're looking for profound professional statements, that's not the place to find those. My website's probably more helpful for that. Just a little bit about me. I've been doing the enterprise IT dance for about 17 years now. The last 5 of it, I've been focused on cloud, both building cloud platforms as well as application architecture. I do a lot of conferencey things. I do a podcast, and I wrote a little free book for O'Reilly a couple of years ago. This is a talk that I normally do in about 90 minutes, and we've got 50. Which means this is going to go a lot faster than I normally do, and you need to listen faster than you normally do. So this is all the stuff that we're going to attempt to cover, talk a little bit about what serverless is and why we care, and kind of compare it a little bit to what the state-of-the-art in cloud-native architecture is up to this point. Then we're going to get into some of the trade-offs that we run into when we're dealing with these serverless architectures, give you a little bit of a tour of what types of offerings are out there, both commercially as well as open source. Going to rant about data for a little bit, and we'll spend probably about a third of the time-ish on some kind of a whirlwind hello world tour of the 3 major cloud providers that are doing serverless stuff, and then maybe a little crystal ball time at the end. So, what is serverless? This term has been around for a little while, and it talks about a lot of things. It really kind of got started in the mobile development space, where I'm a mobile developer. I want to focus on the code for my mobile app on the phone. I know I need a backend for some things like authorization, maybe some data reference tables, what have you, and I don't want to write server-side code. I just want something to give me a backend for my mobile app as a service, and hence the MBAS or BAS term, backend as service, was coined. Not going to really talk about this in this session. This is interesting and useful, but that's not what I came to talk about. The thing that I want to get into is this notion of event-triggered stateless compute containers. This has picked up as a service name of its own. People are starting to call this functions as a service. And this is what we're going to focus on. So, why do we care? Why do we need yet another new deployment target? Why do we need another new architecture to get things done? Part of it is we are climbing the abstraction hierarchy yet again. Can we get even closer to all I write code-wise is business logic? I don't actually write any of the boilerplate operational logic, build scripts, anything like that. All that kind of goes away, and we're just going to focus on the business code that differentiates us from anyone else. Now, are we there yet with functions as a service? No. Are we closer than we've ever been? Yes. Would we like to get there? Probably. I don't know. Maybe you like writing boilerplate code. I don't know. But this is the first motivation. Can I just write business code? Second motivation is I don't want to run things anymore. What do I mean by that? Well, even if you write, stateless microservices, going to deploy them to a cloud platform, you're doing all of these things. Even if you're not thinking about infrastructure, you're still running something. Meaning that if a request comes in to your service, there has to be something there to respond to it. And in our current ecosystem of architectures, that means there is some container, maybe it's a servlet container, maybe it's some other web server that is responding to requests. And for it to respond to requests, it has to be running. meaning that we have to monitor it and we have to keep it healthy so that when those requests show up, it's ready to go. If requests are not coming in, we still have to keep it running because we don't know when the next request is going to show up, which also gets to the point of cost. If I'm running these things in the cloud and I don't have any work to do, I'm still paying for that idle time that I'm keeping those server processes running. In the functions as a service world, your code only runs when there's work to do. A request comes in, whether it's an event from some data service or an HTTP request coming in through an API, the cloud provider spins the function up, executes, processes the request, and then spins it back down again. And you only pay for your consumption at the time of executing the work. If there are no requests, you don't pay. And also the burden of keeping those things alive and starting them up and kind of segueing into scale. You know, if I have these wonderful microservices that I'm running and monitoring, I also have to think about how I'm going to scale them. You know, how do I take my baseline traffic, my baseline latencies, all of these, and then adjust based on the saturation of the system? That's on me to figure out. In the FaaS world, most of that's abstracted away. Again, the functions provider is going to look at the amount of work that there is to do and run the number of function instances appropriate to do that work. So this is why we care. You know, we want to get closer to just writing business logic. We don't want to be responsible for operating these services and paying for idle time. And we want scaling to, again, just be something that automatically happens. Now, do we actually deliver on all of that? That's what it's up to us to figure out. But this is the promise. So if we compare that to a lot of the architectures that we're talking about from a microservices perspective today, you know, some people are saying microservices and FaaS, same thing. Other people saying, no, they're different things. Let's compare and you can make your own judgment as to what's going on here. So I do a lot of work in cloud native patterns, and there's a particular cloud native pattern that I've put together called the externalized channels pattern. And the whole idea is that we have externalized from our code the necessity of figuring out how information is transported over the wire, how it's serialized and deserialized. All we're doing is writing applications that can consume generic messages and respond with generic messages on channels. And so a variant of this pattern is what I call the binder variant, which is actually based on Spring Cloud Stream. And I know there's been a couple of talks today on Spring Cloud Stream, so maybe you've gotten some coverage of this already. But the basic idea is that I'm writing these components that are to the right, so the sink, the processor, and the source. A sink component is basically going to take information off of a generic input channel and send it to some data store outside of the architecture. The source is the opposite of that. It's taking data from some source outside of the architecture, maybe an IoT device, and is going to drop it on a generic input channel inside the architecture. And then a processor is specifically only inside the architecture. It's consuming from input channels and sending data to output channels. Now, these input channels and output channels obscure from my components the interaction with the transport layer. So this binder transport layer is actually implementing all of the integration with a particular messaging middleware. So whether you're using Rabbit or Kafka or something else, it takes care of dealing with that for you. And your components, all they care about are input channels and output channels and generic messaging objects that you've created. You look at it from a activity and a sequence diagram perspective. We're starting from this source client, and the source client's going to send a message to the messaging middleware. Transport layer is going to unmarshal that and drop it onto an input channel, which causes my processor component to be invoked. And this is the time when my code picks up. So all of the boilerplate of dealing with the communication, all the boilerplate of dealing with the fault tolerance, all the boilerplate of dealing with marshaling and unmarshaling is abstracted away from me. I just write business code, and then I return output to an output channel. It gets marshaled, it gets routed to another service by the transport layer. This looks suspiciously like what I just described when I talked about how FaaS works. There are some differences though. I still have to write an application that includes the transport layer and the input channel abstractions as part of my service that I write. I still have to deploy that service as a Spring Boot application. I still have to operate that service and keep it healthy. I still have to think about scaling it myself. We take that and we push it into a FaaS-based architecture. This is a little bit different depiction, but again, I want you to notice all of the code that we write is in these squares marked F. These little arrows that are coming from a data service like a database or a queue have a little orange circle with a T. That's to indicate a trigger mechanism. So basically what I'm doing is I'm publishing a function to the provider, and then I'm setting up a trigger. The trigger in this case on the left is on a data source, let's say like DynamoDB. I create or update an object in DynamoDB. That causes a trigger to execute, which executes my function, and then my function in this case is writing some output to a queue, say Amazon SNS or SQS, something like that, Kinesis, what have you. That causes another trigger to be invoked that executes another function, and it stores the result of that process in another database. Now we can also have HTTP triggers. So at the very bottom we have an API gateway that has a trigger attached to it such that when it sees an incoming HTTP request, it's going to trigger yet another function that's going to operate on the data from the previous execution of a function. So we have all these triggers flying around, and some people have said, this is actually, FaaS is just triggers for the cloud. I can't decide if when people say that they're being positive or negative. I don't know that anybody that particularly loves database triggers other than database people, but this is kind of like the equivalent of that for distributed systems, and it can be a very useful thing. If we're purely thinking of our architecture in terms of events, this is often the most natural way of expressing that. But there are some trade-offs. Everything is not happy and wonderful, unicorns and rainbows. First, the thing that we need to think about is the amount of control that we are giving to a particular vendor over our architecture. For me to be able to deliver an architecture to you where you only write business logic, you don't have to run anything, I take care of all that for you. You don't have to scale anything, I take care of all that for you. Guess what's going to happen? I'm going to put a lot of constraints on how you get to write your code. The only way that I can make all those promises to you is to constrain what you're able to do. In fact, that's the only way any of us can make promises to a client or a customer of our code. If I could say, you know what, I'm going to deliver this application and you can do anything you want to that application and it's still going to work. Is that possible? No, you have to constrain at least what the inputs are so that you can decide how to give acceptable outputs. The more promises that you make, the more constraints are going to be placed on you. Now, this may be good for you, this may be bad for you. You have to make that decision. Constraints can actually be really helpful. They give you less decisions to make. They give you less options, and so you can actually be focused by those constraints. But at the same time, if you want to do something that's kind of off of the regular path, then it may be harder, it may be impossible to do, and you may not be able to leverage a serverless platform to do that. There's also the concern about vendor lock-in. I'm going to show you again Hello World on kind of the three big providers. They look similar, but they're all clearly different. And there is not yet a true abstraction layer that we could write to say that my functions are actually portable from platform to platform. So once I make a choice, I make it harder to make a different choice later. And that's just the compute piece. There's also the data piece, which I'm going to reserve some special time to rant about a little bit later. But all of this depends on data, and if your data is not where your compute is, then it doesn't matter how much you can move your compute around. So you can get some amount of lock-in from this. I wouldn't spend too much time worrying about this, though, because you're always locked into something. Anytime you make a choice, the more time you spend building things based on that choice, the harder it is to make a different choice. So you always kind of have to have this on your mind. Your code has to be stateless. You do not have the option of writing stateful code. Why? Because your function is going to be spun down usually every time it executes. In some cases, for an optimization, it might be kept warm for a little while, but you can't make any guarantee that state is going to be long-lived. So if you have an application where you need to write a stateful service, by stateful service, I mean state that's in memory or local to the compute, not state that's in a database or a cache somewhere. I don't know if anybody is watching this, but I can no longer see the time clock, so I'm going to try to finish on time, but it's a little more difficult now. Maturity. These offerings are not terribly mature yet. The oldest of the functions as a service offerings are about 3 years old right now, maybe 3.5, and they're much better than they were when they first came out, but they're nowhere near something that I would call polished and ready for general consumption by all. In fact, it's not even clear, how much they've been really tested with hardcore, critical business applications. We're starting to get to the point now. I was at Serverless Conf a few weeks ago, where businesses are starting to talk about real things that they're building with serverless architectures. But all of those talks also come with, and here's all the caveats. Here's all the things that don't work well just yet. So you need to pay attention to that. Particularly related to this is the developer user experience is not the greatest yet. It's unclear to me how to get into, say, a good test-driven development flow with functions as a service. Not impossible, it's just not as natural to me as it is when I'm doing regular kind of basic Java coding, for example. And one point to make there is if you want to write Java code at this point in time, your option is really only Amazon. The other providers don't officially support Java yet. They're all working on it, but I probably don't want to adopt the first version of that, right? The only real lingua franca of the serverless world is JavaScript. And if you want to write production code in JavaScript, that's fine, but be careful. So what's out there? Lots of providers. The three major providers, Amazon, Microsoft, and Google. AWS Lambda is the most mature of these offerings. Azure's pretty good because it was based on an earlier service that they offered. Google Cloud Functions just went from alpha to beta. You've also got IBM's OpenWhisk offering on their Bluemix platform. There is a offering from Auth0 called WebTask, and there's also a provider called Standard Lib that will operate your services on top of one of the providers. So this is like if I want to go pay somebody to give me one of these platforms These are kind of the major choices that I'm aware of. There's also a decent amount of work going on in the open source space. So the serverless framework is probably the oldest and most visible of these projects. And what serverless really kind of does is brings kind of a Rails scaffolding-like approach to writing functions across the different providers. So I can have a similar dev tool chain that works for Amazon or Microsoft or Google, or also in this case OpenWhisk. I would normally demo that, but we just don't have time. Iron Functions is a serverless platform that you can run in your environment from iron.io. The OpenWhisk offering that IBM operates on Bluemix is also open source. You can pull that down and run it. FaaSlang is really interesting. FaaSlang is a really new effort from Standard Lib. And what they're actually trying to do is create a standard abstraction layer over the different providers, so that if you have the appropriate plugins or shims available for FaaSlang available, you should be able to write your functions to FaaSlang and run them on any of the providers that are supported by FaaSlang. But this is really, really, really young. Doesn't support that many languages, but is very interesting, and I think bears watching. And then in the Spring world that I come from, we're working on an offering called Spring Cloud Function. The programming model is what I love most about this. If you just want to write Java util functions and deploy those, that's what the programming model for this is going to look like. And you shouldn't, for the simplest functions that you write, you shouldn't actually have any necessity for any external dependencies on Spring or otherwise. So all that would be provided by the runtime platform. So again, this is kind of in a pre-alpha state, but development's kind of picked up pace recently, and I expect to see some really cool stuff really soon. Okay, so one last thing before the demos, and that is the notion of data. If you think about the picture that we drew, we've got all these functions, and we have all these triggers, and these triggers are attached to event-generating data sources, whether those are databases or object stores or queuing systems, pub subsystems, whatever it may be. Your data needs to exist in the same place as your functions for your functions to have anything to operate on. And so the compute piece of this, standing up a platform that will run a function on demand, is actually the easiest part of creating one of these architectures. The hard part is creating these event-driven data sources and having them operate at high availability and scale. That's why I think the idea of taking a functions platform that's open source and running it in my own data center is really not all that interesting. So it's like, oh, I don't want to go to Amazon. I don't want to go to the public cloud. I just want to run functions as a service locally. Well, do you have all these nice data sources locally that are going to generate events and being able to tag into your functions platform? No? Well, then you might as well give up, because that's the hard part, which means that if you think about this from a cloud provider perspective, this is a really good way to offer a way to get more data into their data services by saying, hey, here's a really cheap and easy to use compute mechanism that you can leverage to use our data services. And so that's going to encourage more and more use of those cloud-based data sources. So make no mistake, this architecture is useful, but it's also a way for cloud providers to get more business for their data service offerings. Okay, so that's enough talking for now. I'm going to switch gears and do some demo stuff. Okay, so everybody see that? Good. So we're going to do this really fast as, again, a whirlwind tour. I'm going to do kind of a hello world example for AWS Lambda, for Azure, and then for Google Cloud Functions. And there are nice ways to do a lot of this stuff through terminals and automation. I'm going to do everything through the web consoles because that's kind of the easiest way to see and learn what's actually going on. So if we came to AWS Lambda console and said create a Lambda function, one of the things that I think is nice is that they provide a lot of templated examples for different use cases. So I'm going to pick a very basic one called a microservice HTTP endpoint. Now, it starts out by asking me to configure my triggers, and it automatically goes for an API gateway, which is what I'm going to use for this. But one thing to look at is, what are the possible triggers that you can choose from? So everything from AWS's IoT service. If anybody's doing anything with Alexa, the kind of primary target programming platform for Alexa is Amazon Lambda. If you're doing anything with CloudFront, if you're doing anything with CloudWatch for your logs, DynamoDB, Kinesis, S3, all of these things are here. We're going to stick with API Gateway, though. I'm going to call this my Lambda microservice. And we've got some very basic code here that's going to do CRUD operations on a DynamoDB table that I already have set up. We need to create a role for this. So the role is going to give me the appropriate permissions out of the box based on this policy template to allow me to have the permissions I need to connect to DynamoDB. So I could go through and review this. I'm going to take the defaults on everything else and go ahead and create my function. And here we go. So there's our function. We see the code that's already there, configuration, our triggers set up on our API gateway. So I'm going to take this URL here. Let's make that bigger. So we're going to do an HTTP to that. Table name is my table. And that'll issue a GET request. And you know what? I forgot to do something. Let me go to the API gateway. I left this secured. And you know what? It is probably actually easier for me to just blow this away. It takes actually a decent amount of doing to fix this. Sorry about that. So I am going to blow this API away. And I'm going to blow the Lambda away too. And we'll just do this again. Bear with me. Okay, so the thing that I forgot to do was make this open. And that's actually fixable from the API gateway. It's just actually several screens deep, and I didn't want to mess with it. So this is actually easier to do. All right, give it another shot. We've got a new endpoint. And that should actually work. Bad request. Why are you not? The demo gods are not shining on me today. That's fine. Existing role, my Lambda service, microservice role. That should be fine. All right. One more try, and then we're going to give up. Functions. This is what happens when I try to cut corners. And I'm actually going to go to the effort to delete the IAM role as well. Okay. Let's go through the script one more time. And maybe this time I'll not make a mistake. Open. Perfect, perfect. New role. Okay, maybe third time will be a charm. Because this totally worked this morning. I'm really not understanding why it won't allow it to do a DynamoDB scan. Well, I hate to say it, but I've never had this error before. Gotta love being on stage when that happens. That seems fine. So you know what I'm going to do? I'm just going to create we'll create a new table. If this doesn't work, I'm going to give up and show you Azure. DynamoDB tables take a little bit longer to create, though. Okay, so while that's running, let's go make something actually work. I'm going to show you Azure. So I'm going to create what's called a function app on Azure. So a function app on Azure is a container for multiple functions, whereas functions are first-class citizens on the Amazon side. So I create this functions app container, and then once it shows up in the app services list, I'll be able to add functions to it. DynamoDB table still creating. Now this is creating. Fun thing about cloud demos is they take a long time. But that's okay. We're doing okay on time, actually. Something needs to create so that we can actually show stuff. So remember what I said about dev UX. It's not as great as you want it to be. And even if I run this stuff from the command line, I end up waiting a lot. Okay, there's my DevOps table. Let me try this one more time. That's very weird. This has never happened ever. I'm just going to take a look at this role real quick. Attach policy, show policy. Oh, interesting. Thank you, Amazon. They changed what the policy is for the actual template. I can fix that. Or maybe not. I attached the policy. Why is it not working? All right. There it goes. Just needed time. If it's that exciting to get this part of Hello World working, we're in trouble. Okay, good. So let's put something in the table. How about that? That should be amazing at this point. So HTTP post to that guy. Table name, we're going to stick with devox table. Actually, I need to change that to a single equals because of the way this request is submitted. I want to do an item, and we're going to send it a JSON object. So that needs to be a colon equals. Foo, not foot. We'll say ABC123, hello, devox. All right. Do a get, and we should get our record back. Yay. All right, so now that actually works. I'm feeling very redeemed now. Let's go do some Azure. All right, so my devox function, let's go in and put that in. So I'm going to show you something interesting based on some code that I already have. I want to demonstrate this idea of Azure bindings, which really only show up in Azure. So I'm going to create a webhook plus API based on JavaScript. And I'm going to drop some copy-paste code in there. So what this first piece of code is going to do is pull out of the incoming event a key and an array of values. And it's going to take that array of values and it's going to shove it in an Azure table. Now, the interesting thing about this is that we're going with a JavaScript array, and we're assigning that JavaScript array to context.bindings.output table. I am then going to push an object, just a regular JavaScript object, onto that array. And somehow that's going to magically end up in my database, even though I'm not actually talking to a database API. So how does that actually work? I'm going to grab another file here called function.json. Going too fast. There we go. So we'll go over here, view files, drop in this code. So our bindings are going to represent our inputs and our outputs. I've got an HTTP trigger for in, I've got an HTTP output binding, and then I've got this thing called values to store, which is a connection to Azure Web Job Storage. And it's called output table. So what's happening is I'm taking output table, which is a JavaScript array, and by pushing objects onto that JavaScript array, Azure is behind the scenes taking those objects and shoving them into this database based on the fact that I declared this binding. So what I can actually do now is I can grab a request, and we'll just test it through the console here. And we should actually be able to shove those values into the database. So we've got 42, 27, 12, 2017, 1800. We're going to write another function that's going to pull those values out and sort them. So let's go ahead and go with another, let's see, I want JavaScript, and I want a generic webhook. That's fine. Let's grab this other code. This is really ugly JavaScript code. Please don't ever write JavaScript code like I write here. There's a bunch of junk here that takes the string representation of the array and turns it into a numerical representation of the array so that I can sort it. But it's not terribly pretty code, but you know what? It works. That's what I care about right now. And let's grab our bindings to see what's actually going to happen here. So view files again, function.json. So what we're doing here is very similar. We've got the same input and output, but now we've got table name values to store in Azure Web Job Storage called output table, but the direction is now in. And we have a row key that is now called key in curly braces. What we're doing there is we're going to take the local binding of key inside of our code, and that's going to get passed into this binding to say load that one row from the output table for this function execution. So if we go back to the code, you see that key is coming in as part of the event data. That key is magically bound so that when I refer to context.bindings output table values, it's actually going to load the row based on key so that I can actually sort and work with it. So, moment of truth, we're going to take the same key, my devox values, and we're going to test it out on this function. And if you look in the output down there, you see sorted values 12, 27, 42, 1800, 2017. So, first time, we got that one right. So now let's do something very, very simple. Let's do Google Cloud Platform. Now there's some magic that the other providers do that Google Cloud Platform does not do for you, which is when you write your code, they actually stage that in an object store bucket for you before it's deployed. To do that, they actually create that bucket for you. Google Cloud does not. So I need to create a bucket first for my function. We'll call it hello devox FaaS or something like that. That works. We'll just leave it in the US for now. Okay, so that's good. Now let's come over to Cloud Functions. And we'll create a function. We'll call this hello Google Cloud Functions. We'll go with hello world topic. And I'm going to grab my code from here. Drop it into the editor. And I want it to use my hello devox stage bucket. And the function to execute is called hello world. So we'll create that. So that will run for a moment. And so this one is actually going to be bound to a Google Pub subtopic that we're going to send messages to. And then we're going to be able to see that it writes things out to the logs. So I'm actually going to test this out from the command line as well, using the gcloud tool. So we're going to call our hello GCF function, and our data is going to be message hello world. Code not found. Hello GCF does not exist. That's because I didn't call it that. Try it again. Okay, so execution ID, we got that back. So now I should be able to look at the logs. And there we see my devox function hello world. So the message that we printed out to the logs is actually in the logs. Okay, cool. So we made it through hello world on all three of the providers. There's obviously a lot more to say and talk about, but really what I wanted to give you was just a sense of what the development flow as your first learning looks like, going through and kind of what a very basic getting started experience might look like across them. There are all kinds of other things to talk about. How do we bind to and integrate with other data sources? How do we chain functions together? How do we do testing? Don't have time to talk about all those things right now. One thing that you can do from a testing perspective is all of these now have basic simulators that you can pull down and run a test environment locally on the laptop for doing round trip on your functions and then push things up through buckets. You can deploy things from GitHub repositories directly. So there's a lot of other stuff to talk about, but this is kind of just a very quick overview of the providers. So coming back to my slides quickly. So crystal ball time, very quickly as we close. Where is this going? Would I build my mission critical enterprise business application on top of this today? My best answer is maybe to probably not. And simply because I just don't know how to do all of the things from a testing and deployment pipeline perspective. I don't know how to do all the things related to monitoring. If you were in my resilient architecture talk earlier, all the very rigorous stuff that I want to do from a monitoring of my architecture perspective. No, I don't have server processes that I need to keep healthy anymore, but I still have an overall system architecture that I need to understand its behavior. It's not completely clear yet how we do all of those things well. Is it growing? Is it maturing? Is it getting better? Yes. Now, fast forward 2, 3, 5 years down the road. Are you going to be doing something with a FaaS platform? I would say probably yes. Especially if you're already doing stuff with a cloud provider today. Let's say I'm already friendly with Amazon or Google or Microsoft today. I'm already deploying workloads there today. These providers are very invested in getting you to use their functions offerings. Now again, why do I think they're really invested in getting you to use their functions offerings? Because they want you to use their data services. So if you already use their data services, you're going to start to see really interesting and useful applications of the FaaS runtime, of the FaaS abstraction that you'll be able to use as a part of your architectures. Are you going to create an entire systems architecture just out of functions in 3 to 5 years? Maybe for some apps, probably not for all apps. Probably never for all apps, because if you have some apps that are by nature stateful, unless the restrictions on the runtime for state are actually relaxed, you just can't possibly run them there. So it's a good time to learn and get familiar with how these platforms work, how you do architecture and development and testing in these environments, so that in the next 3 to 5 years, when you're called upon to actually work in this environment, you're already kind of ramped up and ready. And that is the end of my talk. We've got about 90 seconds if there are any questions.
Spring Cloud function.
Yes?
So that all these functions are too small to run Spring there. So what is the idea behind Spring Cloud function?
So the idea for Spring Cloud Function is kind of multifold. There is a really nice Java-based programming model, and then there is a runtime environment. The runtime environment essentially ends up being your function as sucked into a Spring Boot scaffolding that actually provides the runtime environment for your function, but that's actually abstracted away from you. So you still have your function that you write as just a standalone, and then you deploy it into something that ends up being a Spring Boot based container. And we're looking at various deployment options for that. Obviously Cloud Foundry, but also Kubernetes-based platforms and others. So it's still very early days, but the idea is eventually to get to something that looks very much like the experience that I demonstrated with the major providers, but you're actually writing Java util functions and you'll be supported by Spring. And that's all my time. So thanks very much.